Alright guys, so in this lecture what we are going to look at is the conversion of benzene to benzylic acid. Now the reaction is a 1-2 rearrangement, or we can say 1-2 molecular rearrangement. Is that okay? That is the reaction that converts benzylic acid to benzyl to benzylic acid. Now the first question I actually have here is the conversion of benzyl to benzylic acid is what type of reaction? So we have first one, question 1. Conversion of benzyl to benzylic acid is a 1,2 molecular rearrangement reaction. This is a potential question. Molecular rearrangement reaction. All right. Now, the next one is write the equation of reaction. Now, the equation of reaction, which is question 2. Now, most times you should always get very used to the equation of reactions, because if you write your equation of reaction wrongly, there is tendency that your calculations will be very, very wrong. So we have benzyl. Now, what is benzyl? It's something like this. We have something like this. I'm going to use this C double bond O. Then we have C. I'm going to put double bond O here, and then of course you can write it this way. Whichever way you want to write it is actually very, very correct. All right. This is what? Benzyl. What are you going to react it with that it will give you benzylic acid? You react it with a base like KOH. So this will give us benzylic acid. What is the structure of benzylic acid? Now, benzylic acid is in such a way, let me try and bring it out, that you have an OH here, then you have COOH group, and then you have, if I'm right with my drawing, this should be straight at least. So this is benzene ring, and this is another benzene ring. All right, so this is the structure of benzylic acid. So this one is benzyl, while this is benzylic acid. Now, question 3. So this is the equation of reaction. Let's take question number 3. Question 3 says, write the mechanism of the reaction. What do you think the mechanism of the reaction looks like? So to write the mechanism of reaction, we'll first of all draw the structure of benzyl. Of course, we told you that benzyl, something like this. All right, and then you have C double bond O. Then let me bring it down. C double bond O, and then you have okay, we can actually take it from here and draw it upward. Can take it this way. Is that okay? Now, what is the first thing we are going to react it with? We are going to react it with the alcoholic OH of potassium hydroxide, the basic part of potassium hydroxide, of course, which is the OH, not alcoholic OH, the basic part of potassium hydroxide. So react it with what? OH negative. OH negative will actually come here. All right. Now, when it comes here, what are you expected to form? you form a product that looks like this. Should be very careful of the way you draw this so that you are not going to, of course this is carbon. Now as the OH is coming here, valency of carbon will exceed, sorry about that, the valency of carbon will exceed 4, so this one will come up here, right? So what are you going to form? You're going to form O negative, and here you are going to have the OH attached. This OH is what is coming here. Is that okay? So, and then at the end of the day, you are going to have C double bond O, and then we have something like this. Now Tombra actually did this in class, and I think there is tendency for him to bring this particular one, Dr. Tombra. All right, now having done this, the next thing we need to do is very easy. We move this ring here, all right, with its methyl group. We actually move it this way with its methyl, with its bond. We move the bond here, and then what we do is to bring this one here. The general idea is that if this O negative is coming here, the valency will now be 1, 2, 3, 4, 5, which cannot be. So this one will break from here and attach here. So what we are actually doing is that we are cleaving this bond from here, taking it away from here to this position. Is that okay? So what are you expected to form? You will form something like this. All right, this is going to form something like this. All right, this bond will no longer be here. You know why? Because you've promoted it to this position. So what I'm going to do, I'll first of all draw this carbon here. You've promoted this bond to this place, right? This carbon here is this one here. Are you getting it? Now as I'm actually bringing this here, what will happen is that the valency will also be more than at this position, because as this one is coming here, the valency will be more than, the valency will now be 1, 2, 3, 4, 5. So this one will also pack up here. So at the end of the day, I'm going to have here as O negative, then I'm going to have this benzene ring. All right, good. Is that okay? And then I'm going to have this other benzene ring attached. You can actually see that we said it will move from this place to this place, so it will attach to this one here. So this is the other benzene ring attached at this position. You can put it anyhow you want to put it. Now also you can see that this bond has another linkage. You can see it here. There's a linkage here, which is this one here. Now what can you actually see there? You can see C, O, because if this one comes here, it's going to give us something like C, right? Here will now become double bond O, because as this one is coming here, it's forming double bond, and here will be what? OH. So we can rearrange this right there to give us, now please note, this is not a double bond, this is a single bond. We can rearrange this in such a way that this O2 will give us C, all right, this bond here, then this one also comes, then this one here, and then of course we still have this O negative. This bond here, we can put it, it's still the same thing. Now we can move it to this side. What do you have here? COOH, which is a carboxylic acid group. So we have COOH. Now if this one undergo acid hydrolysis in the sense that you put H plus through this position, that means it actually abstracts a proton. The proton will come to this place to neutralize this and give us OH. So this is going to give us C, and here will be what? OH. Here will be COOH. Then you have this and this attached. All right. Here will be this, and then this. Is that okay? This is benzene ring. And then here still be the same thing. For me to draw with this stuff is all right. So this will be benzylic acid. So that is the structure of benzylic acid, and this is what you have here is the mechanism of reaction. All right. Now that you've drawn the you've written the mechanism of reaction, the next thing is give a brief background of the experiment. Now, of course, the experiment talks about benzylic acid with KOH. Are you getting it? So firstly, you are going to benzyl is a crystal. So you are going to dissolve first, weigh your benzyl, all right, dissolve the benzyl in solution of KOH in 50% aqueous alcohol. The alcohol used is ethanol. Then you warm it with hot water. Okay. Now, when you react this to and warm it with hot water, it's going to form sodium benzylate. Are you getting it now? It's going to form what? Sodium benzylate. Now, first of all, in hot water, and then after that, you actually take it to an evaporating ditch. All right. After the evaporation and the resting, crystals of sodium benzoate will be formed. Now, these crystals of sodium benzoate, you actually wash, first of all, you wash with cold water and then crystallize with methylated spirit or methanol, hot methanol. Then after crystallization, you will dissolve in 20 ml of water. That is, first of all, you are going to form what we call potassium, not sodium, because you use potassium in this case, potassium benzylate. That is the first thing is going to form. Then this potassium benzylate now, you react it with HCl, hydrochloric acid, which we hydrolyze, or let me say acid hydrolysis of the benzylate to benzylic acid. So the procedure is very somehow, but you just need to understand. First of all, weigh the benzyl, dissolve it in 50% in KOH in 50% aqueous ethanol, then warm in hot water. After warming, then place in evaporating ditch. Are you getting it? Then after placing in evaporating ditch, you are allowed to cool, and then at the end of the day, what will happen is on standing, you are going to have the sodium benzylate. Are you getting it? Then the sodium benzylate, you wash it with cold water, and after that, you add small amount of methylated spirit or methanol to crystallize it. Are you getting it? And then you are going to get the benzylate. Then at the end of the day, this benzylate now, you put it in water and then dissolve this benzylate, because this benzylate will also be a crystal, solid crystal. You dissolve it in HCl to convert it from benzylate to benzylic acid. Then you recrystallize again with toluene, in this case, either with hot water or toluene. Then you dry and determine the melting point. So the other crystallization is either with toluene or it is with hot water. hot water. All right. So that is that for this one. Then the uses, you can go and look for the uses, browse the uses.